Hey everybody, Jason here. Today I'm going to be working on an iPhone X that was sent here all the way from the Netherlands. This thing was sent in because it has no power. Let's see, I have an iPhone X with no power issue. The main story, the previous owner went to a repair shop in my home country in the Netherlands, and they had put on a new screen. After a few hours, the phone was getting warmer and warmer. In the end, the phone turned black and does not turn on anymore. iTunes also does not recognize the phone. I can't really read today. I really hope you can fix this, and I was wondering if you would like to make a YouTube video on this repair. Now, this is something I don't normally do, but for the low price of just $49,999, $99.95, we can do a video on your phone. Let's have a look at this thing and see what we are up against. Let's pull it out of the basket first. Here we go. Let's see, is this... Oh, I thought I seen electrical tape for a minute. Okay, so it looks like we have the screen separate. I am so used to getting things in bags and such. Alright, so what do we got here? We have a screen assembly with no real strong defects that jump out at me. I'm going to throw this saran wrap directly in the trash. Alright, let's have a look at the rest of this box here. Okay, I see some things here. Let's get this out of the package and throw the package aside. It looks to me, gosh, and I'm really concerned. It looks like we have cut this sticker right here, or somebody has cut this sticker right here. And the only reason that I've ever cut this sticker is if I was going to separate the PCB. So I would think that that was in preparation to separate the PCB. However, the foam like waterproofing pad thing that goes around all these connectors, it has not been crinkled, but on the iPhone X, I have been taking these off. I'll do the board separation, do my repair, put it all back together, and then I put these back on. These peel off real easy. So that not being crinkled doesn't really mean that this thing hasn't had the board separated. Let's go ahead and look closer. Let's look at this under the microscope. Before I even start unhooking anything, I'd like to know what I'm getting into. So here we are under the microscope. We can see that that has plainly been severed. And if you look closer, you can tell that this thing has had heat all over it. Got some crap broken off here. And it went to a repair shop in my home country, and they had put a new screen. After a few hours, the phone was getting warmer and warmer. In the end, the phone turned black and doesn't turn on anymore. iTunes doesn't recognize it. So that's the main story. What I'm not getting here is the secondary story, like... Tell you what, I love working on the iPhone X when it's not a prior repair attempt. Look at there, 3 screws. Yeah, how about that? 3 screws, and the logic board is coming out of this phone. Gotta get down in here and unplug this thingy. There we go. 3 screws, and don't forget the SIM tray. There we are. Now you gotta watch one of the Face ID flexes when you're taking the board out of these. Come on, mofo, don't make me look like an idiot. There's a Face ID flex over here, and it's got a way of getting caught on the board. And I accidentally tore one once, and I was lucky enough that it was in for data recovery. I see a hint of some liquid here on the bottom of it. You know, on the iPhone X, many of them have been repaired now without having to separate the board. So that's always a hope of mine. Let's see. Let's get it right under the microscope and see what our board joints look like. Well, guys, I think I may have just been blowing off steam. Look at this. Looks like we've got pretty good. You know, the guy explained that the phone was getting hotter and hotter. Maybe the evidence of heat that I'm seeing here is from the phone getting hot. You know, if you ask me, I would say somebody's been messing around. I mean, Look at the solder here. Does this not look like it's been separated before and this sticker's been peeled back? Was this phone having... We're not getting the whole story here, guys. That's what I'm finding out here. We really don't know. First, let's find out what this is missing down here by the battery connector. Let's find out what that is. For this, I'm going to go ahead, I'm going to load up phone board. Let's browse here. We're going to open up the iPhone 10. I'm going to go ahead and choose Qualcomm because it most likely has data. All right, let's get in and look at our battery connector here. And what we're missing here is C3351. That is just a battery on a cap on the battery line. We're not going to worry about that. So the next thing we're going to do, let's look at the behavior of this board. I'm going to go ahead, I'm going to get it hooked up to the DC power supply. This one does not have any mention of data. Blah, 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 blah. Blah, 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 blah. Okay, no mention of data. We're just going to blast this thing with some juice here and see what happens. We are going to grab our iPhone 10 lead. There we are. And let's cautiously turn it on. There we go. The power supply is set to 4 volts and 3 amps, and I'm going to push the, I'm going to turn the supply on. There we go. The supply is instantly drawing 3 amps of current. Now, this likely means that this board has a short on VCC main. Honestly, did not think this was going to be a VCC main short. That could be why we've got a cap missing there on VBAT. Let's take a couple of readings with the multimeter and just kind of, let's poke around here. We're going to check and see if this short is on the battery line. Let's see if maybe it is on VCC main, which it most likely is, or VDD main, whatever you would like to call it. So I will be putting my black probe on ground, and I'm going to use my red probe to check thingies. Dear God, did they unsolder this shield from the top? This looks like this has been unsoldered. It's pretty difficult to unsolder this shield without messing with the solder joints between the board halves because they melt way lower. All right, black probe on a shaky ground. And let's check this thing. On one side of it we get 0.6 and on the other side we get 0L, so that's not an issue. Let's check VCC main. Now on the iPhone 10, we have VCC main coming directly out to the display connectors, and let me show you what I mean by that. On this side of J5700, we have VDD main. Okay, so let's check VDD main there on J5700. We're going to check for resistance measurement to ground. And we're getting a 0.6. So this board is absolutely, positively, beyond a shadow of a doubt, going to have a short to ground on VDD main. Only with the iPhone 10, if you look at the top side of the board, there's just, there's not hardly anything here. I've got VDD main selected, and you've got just a couple of things out here that it might be, but once you heat the board up to the point where you can desolder this shield, it's already completely molten. You can pull the two halves apart. So it just doesn't make any sense to troubleshoot a VDD main issue on an iPhone 10 without separating the board. So it's like step one, separate the board. Here we go. We're going to slip it in here. Yeah. There we go. And now we're going to turn it on. So I'm going to leave this sit here until it is warmed up and is completely molten, and then I will come back and proceed with this repair. Okay, here we are back with this thing. I think it is just about up to temp. So what I do on these, I get down really close and I just kind of push on it. Okay, I see that we've got some movement. You probably won't be able to see it there, but I'm not going to readjust the camera this time. If you look through my videos, I got a couple of them, I think, separating the iPhone 10 PCB. But we need it to be pretty well molten all the way around. This one is not quite there yet, but here in just a couple more seconds. The whole thing's hot. And here we go. I'm going to gently insert my tool and begin lifting this up. Ah, fuck that one up.
Babe, get out of there.
I'm never coming out. My life is ruined. We're going to take this out of the holder. Ow, it's hot. Here we are. Little spatula there. Now, let us quickly decide if this is a top side short or a bottom side short. And you know what? So far, our balls look pretty good. I might have gotten lucky and dropped it in such a way that it landed on the components. It didn't actually land all over the balls. Alright, I don't see anything visibly that jumps out at me so far. The PMIC doesn't look too bad. It's starting to look a little more liquid damagey, right? Alright, so that's the top side. Let's grab the bottom side. You know, the solder on the bottom side don't look that bad at all either. I'm gonna wind up dropping this right back together. You know, you can tell when they put these together that they put them together with some force. That's how this adhesive gets smashed down. So I've been doing it a couple of ways. If I do wind up like doing any kind of clamping, I come back through and I give it one last float so that we get a good joint between the two board halves and not like a smashed joint. Alright, let's see what side this is on. First, we're going to grab our top side here. Here's where we were checking for our short before. And I'm going to do the same thing here. We're going to put our black probe on ground, and we're going to put our red probe on VCC main and see what we get here. Oh, we're not in auto. 1.6 mega ohms. Am I measuring in the right spot? That's more like it. 0.5 ohms. Alright, so the short is here on the top side. We're getting 0.5 ohms to ground. So this is the Flare 1 Pro. The links for all of the tools that I'm using are in the description below. And this thing is most likely going to make this short jump right out and slap me in the face. Now, let's go ahead and get this ready. For this part of our little experiment here, we're going to connect the same supply that I used earlier. We're going to connect this right here. I'm going to go ahead now. We're going to dial our supply back a little bit. The supply, we're going to want it set. I'm only going to allow this thing to pull 2 amps. So I'm going to dial that back to 2 amps. Let's get our thermal camera up and going. Now, this camera works really well as long as we adjust the MX distance. You'll see that we've got 2 images there. We've got a thermal image and a visible image. And when we adjust the MX distance, we can get those 2 things to line up, okay? Now we're going to adjust our temperature range. We're going to turn it down so we don't really see anything glowing. And then we're going to turn the supply on. And 1, 2, 3. There we go. Okay, now what we see glowing there is most likely the equivalent of like Q1403 on the 6S or 6. We want to see what else there is. Okay, so we've got 2 main spots here that are glowing, and I'm sorry, I'm trying really hard to hold this camera still, but I'm not doing a good job. We've got 2 things that light up. One is right here. This is Q1403. Or whatever it is on the tin. But then we've got something else back here that lights up. Let's look at that really close. There's 2 things that light up. Boom. 2 things that light up bright. It's here and here. So people have said that the FLIR isn't a high enough resolution to troubleshoot this stuff, but I mean, I can plainly see which component that is. So let's throw the thermal camera aside now. Well, not really throw it because it's fucking expensive. And let's get this under the microscope. And there it is. There is our little demon right there. So the first thing we've seen light up is this little MOSFET. Okay, this little MOSFET is going to be what connects the battery rail to VDD main. So when we have a short to ground out here on VDD main, it has to go through this little thing first. So if we were to take this capacitor right here that looks like hell and just get our tweezers next to it, looks like we've got, no, it's just flux. So we get our tweezers next to it, and we're just going to go and shoot that little prick off the board. And now, let's go ahead and turn the power supply back on. We are now drawing 0.01 amps. So this thing is just very straightforward, short to ground on VDD main, and it was caused by a single bad cap out here. Whenever it comes to a VDD main cap, depending on its location, I wind up opting to not replace it. If I wind up heating this board up to the point of being able to replace this cap that nobody will notice missing, then we have always a chance of floating a ball somewhere or causing oxidization under something else. So in cases like this, I get rid of the cap and put the crap back together. I mean, despite the flux and stuff that's on this thing, this board actually looks pretty good. Most all of our solder joints still have nice little bubbles on top, or nice little domes on top of them. So let's get it back into our thingy. Where's my thingy? I know a lot of people have been doing these reassemblies on the iPhone X in many different ways. I have been loving my easy method here, and I've had a reasonable success rate. Now, some of them sometimes wind up being, crap, the mic's all the way over there. I hope you can hear me. I'd like to apologize for the hiccup there with my audio, but if I were to now want to test this in my eye socket, I would have to clean the flux off of this, only to put flux back on it, and blah, 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 yada, yada, yada. We are going to just go ahead and put this board back together. I've got a reasonable enough success rate with this procedure that I'm confident that it'll work. I'm not near as confident in my ability to manage my recording gear. Let's see, I'm gonna go ahead, I'm gonna put a little bit of flux on this, right? I don't know, it looks pretty damn fluxy. We got some dry spots. I'm gonna go ahead and turn the burner on to be sure this starts to warm up. I'm not gonna like douse it in flux, but places where I think we might have a dry spot or two, we want this to go back together and work. And there's a lot of connections here, man. Luckily, there's a huge amount of ground out here where, you know, things tend to pull apart. There's a lot of ground out there. You can deal with some pulling apart. So we've got it fluxed. I've turned the heat back off because I don't want this to melt just yet. And I'm going to sit this back on here. Wow, did I just nail it? No, of course not. All right, we'll take it. We're pretty well lined up all the way around. Now what we'll do is kick that burner back on and let it heat back up and settle down on there. I'm going to leave this heat up for a while and then come back to it. Hopefully I don't forget to put my microphone on. We are back with this thing. I've changed my stuff around. I can't get you the angle that I've gotten on my previous iPhone X videos. Basically, what I'm going to do here is I'm going to push on this board and check it. Okay, this is molten up here. We're going to push down here. This is definitely molten. I can see solder squeezing. Looks good. And as I do that, I'm looking to see if the board's teetering. It's not. It seems pretty flat. I still like to push down on top and bottom in various places. And I moved it a little bit just now on accident. And I believe I've seen the board snap back. Okay, so everything's looking good. I don't see any gaps. So we're going to go ahead and turn the heat off. Now, by pushing on it and letting it go, we've smushed the solder down and we've let it spring back up a little bit. So there will be just the tiniest bit of spacing between these two boards, but it really shouldn't even hardly be visible. So we've got the heat off. Now I'm going to let this thing sit here until I'm dang sure that we don't have any floaty business going on. That looks really good. I don't see hardly any spacing. It didn't even raise up out here at the end like they usually do, or sometimes do. All right, I'm gonna let this sit here and cool off for a minute, and then I'll be right back. All right, I think we're cooled off enough. I'm gonna go ahead and start pulling this out of here. Slide the blade under it carefully. Still being extra cautious because it might still be molten. If it is, very shortly after it leaves this heater, it will not be molten anymore. Huh, the camera view there actually makes it look like the whole entire board's bent. but it's not. It's actually, it's a bubble under the sticker. Almost gave me a damn heart attack. All right, so we've got our board out. We've got it soldered back together. Let's look at it under the microscope, and then we'll put it back in the housing. So here we are under the microscope. And as you can see, even out here at the very end, it went back together nicely. How about out here on the outside? Also went back together very nicely. Down here it looks like it could be misaligned, a fuzz, but it went back together very nicely. So let's get this back into the housing. So here's his board. Let me get something to clean up this mess. For this process, I'm going to be using a standard napkin. I'm going to squirt some alcohol on it. Now for the moment of truth. There's our customer's housing, our customer's PCB. We're going to slip it right in there. Okay, now we're going to turn the power supply on, which we should not be drawing no crazy 3 amps of current anymore. We are not. And we're going to press the button to boot. And 1, 2, 3, boot. I love working on the iPhone X. Now, I will say that that's right, I tripped over my tripod. My standards for what amount of flux that I'm willing to leave on the board, you know, you see all these manufacturers that, you know, they do clean them before sending them back out. But once you heat the board up, you'll see flux just comes out from under everything, and they can really only clean it on the surface. It doesn't really ever get cleaned under the chips. Now, ultrasonic cleaning will come close, but still, it's not really necessary if you have a flux that's not very corrosive. This one, should I take it back apart and clean it? This phone finished booting. It is up and running. Let's swipe our Face ID thing and it should come up and ask for a passcode. It does. So here's our emergency screen. And we have working touch. I don't have a passcode, so I can't really verify that baseband's working. I guess I could put a SIM card in it. I need to check Wi-Fi and baseband, but for the purpose of this video and solving the mystery with this phone, that is going to be the end of this video. My nitpickiness, OCD, whatever you want to call it, is about to make me take this back apart and clean it, because it's like, I like to send stuff back out clean. Anyways, guys, that's going to be the end of this video. If you like my video, please click the thumbs up button. If you're new here and you haven't subscribed and you like these videos, please subscribe. And as always, the tools that I use in these repairs is linked below. So I'll see you soon, everybody. Have a good day, and thank you for watching. I could not, in good conscience, send this thing back without ultrasonic cleaning it. And I had noticed I had left one little piece of like solder behind when I went back and reviewed the video. And this thing, I think it's pretty well clear-cut liquid damage. I mean, you can see this bit of corrosion. I don't wonder how that coil got cracked. But you can see this corrosion taking place on these caps. Now, whether it's liquid damage because of nasty ass flux that Apple left on it or whoever worked on it last. You know, whether it's liquid damage because of that or if it took a spill, I'm not really sure. Honestly, it looks like just kind of sloppy manufacturing. I've spotted a handful of crooked components, and you know, I could deal with a little bit of flux on my conscience, or in this one's case, a lot of flux. But as I reviewed the video footage, I'll clip it in right here. I seen a hunk of solder I'd left between the board halves, and that I cannot live with. So I took it back apart. I gave it a good proper cleaning, and we're going to continue to leave this cap off of here. It's just not worth replacing it. And yeah, there you go. Why do the job once whenever you can do it twice, right?